All right, good morning or good afternoon here. I'm going to have you just listen to this and take notes down on section 7.1 and then complete the homework or get as much done as you can in class. We'll try and finish up grading your tests and take care of a couple other things with some of the people that are in each class. But if you take a look at, and we're going to move in forward into chapter 7. And chapter 7 deals with a lot of applications of trig. First being the law of sines, and then we'll deal with the law of cosines. Law of sines, you've had in the past, probably in Algebra 2 last year. But the first thing we're going to do is we're going to derive the law of sines. So you should have your guided notes there. And let me go to the next slide here. And so you got this figure here. Now the law of sines, and then when we get to them, the law of cosines work for any triangle, not just right triangles. Up till now, we could only use like sine, cosine, and tangent for right triangles. But we're going to now develop some rules, the first of being the law of sines that will work for any triangle. Well, you should see on your figure, you already have drawn in the altitude from angle B to side B. And the altitude is going to form a right angle with the side it is drawn with. So we're going to create two right triangles. Okay, we got this smaller right triangle to the left, and we got the bigger right triangle to the right. And so what we want to do is we're going to develop this right here. This is our law of sines. Now we only use two at a time. You only use like sine of A over A equals sine of B over B, but all three of them are equivalent. Okay, using the triangle on the left, what would the sine of A equal? Well, it's still opposite over hypotenuse. Well, at this point here, opposite is not marked, so we're going to put that in H for height. So the opposite side would be H. The hypotenuse would be C for angle A. All right, and the other triangle, take a look at angle C. Okay, what is the sine of angle C? The sine of C is going to be opposite over hypotenuse. So in this case here, it's going to be H over A. All right, well, I'm going to use these two facts to develop two of these and set them equal to each other. Well, these two do not have the letter H. So go ahead and get H by itself in both of them. If I multiply by C on both sides, I can get H equals C times sine of A here. And then the same thing here, if I multiply both sides by A, I get H equals A times the sine of C. Well, since they both equal H, okay, I can take this C times the sine of A and A times the sine of C. And since they both equal H, I can set them equal to each other. So C times the sine of A will equal A times the sine of C. Well, I'm going to have to develop here. I'm not going to be, not dealing with B. So here's where I want to end up with. I want to get the sine of A over A equals the sine of C over C. And so I'm pretty close here. I got the sine of A and sine of C. What I can do is I can divide both sides by C, and that gives me the sine of A, those cancel, equals A times the sine of C over C. And now the next thing you're going to do is divide by A. Even though that C is already there, that's fine. Divide by A. And now I get sine of A over A equals, those cancel, sine of C over C. And so I have my rule. And now if I would rotate the triangle and draw the altitude from a different spot, I could work angle B in there. But now I got these two are equal, and that's basically what I need for the law of sines at this point. So always take the sine of the angle and the side across from it. Now we talked about this earlier. Anytime you draw a triangle, wherever angle B is, side B has to be opposite it. Wherever angle C is, opposite side has to be C, and wherever angle A is opposite, it has to be A. That always has to be the rule when you're drawing out a triangle. All right, let's use the law of sines to find some missing sides and angle. All right, now I want you to solve this triangle. Anytime you're asked to solve a triangle, you need to basically find all missing sides and angles. Well, I'm going to take a look here and I'm going to try and make this reasonable. So like 62 degrees and this is 74. I'm going to label this A. I'm going to label this one B and this one's going to be C. So 62 degrees will be here. B is 74. And now side C has to be across from angle C. That has to be 14. This is what we call an angle side angle case. The side is between the two angles that we're given. Okay, and it has to be directly between those. So this would be angle side angle. Well, to find the angle C, you just take that, add those two up and take them away from 180. So for angle C, you just take 180 minus 74 minus 62. I'm going to get 44 degrees. All right, little bit harder, finding side B, finding side A. All right, so we know this is 14, and I know that this is 44. I'm going to have to use these to get side A first. Okay, I'm going to use the fact that sine of C over side C is going to equal the sine of angle A over side A for that case here. Well, C is 44 degrees, so I get the sine of 44 degrees over 14 inches equals the sine of angle A, which is 62 degrees, over side A. Basically, you got a proportion. We're going to cross multiply to solve. So you're going to take A times the sine of 44 equals 14 times the sine of 62, divide by the sine of 44, divide by the sine of 44. So I get A equals, and now using my calculator, 14 times the sine of 62. Hold on here. Oh, I'm in radians. I need to be in degrees. And I knew that shouldn't be a negative. All right, start that over. 14. And make sure you're in degrees. Times sine of 62 divided by sine of 44. And that gives me, and I'm going to round to the nearest tenth for all my sides, 17.8 inches. Okay. Now, and for any side I'm looking for, I want to avoid using any rounded off values if at all possible. In this one I can, because I can use the 44 and the 14, and now I'm going to use angle B and side B. So I'm going to take the sine of C over C equals the sine of B over side B. So that gives me the sine of 44 over 14 equals the sine of angle B, which is 74 degrees, over side B. All right, same thing. Cross multiply. B times the sine of 44 equals 14 times the sine of 74. Divide by the sine of 44. And I get, let's see here, 14 times sine of 74. And that equals 13.5. But don't round off here. Wait to the very end. Divided by sine of 44. And I get 19.4. So side B is 19.4. Just to double check, remember from geometry, so we said A was 17.8 and we found B to be 19.4. In geometry, the side across from the biggest angle has to be the biggest side, and the side across from the smallest angle has to be the smallest side. The sides are going to be proportional to the size of the angles. So that's the biggest angle, 74 degrees, 19.4 better be your biggest side. 44 is our smallest angle, 14 better be our smallest side. And then 17.8 is going to be in between the two, which means 62 is going to be in between there. So that's always a double check, just making sure, you didn't make a careless error. All right, that was that first one there. All right, second one here, 112 degrees is an obtuse angle. So I am going to let this top angle be angle B because clearly that's the biggest angle. Angle C is 32 degrees. I'm going to go over here and let this be 32 degrees. And that leaves angle A over here, which we don't know at this point. And we know side B is 21, in this case, 21 miles. All right, this is a case. The first one was angle, side, angle, because the side was between the angles. This is what we call angle, angle, side. You get two angles, and then you got a side, what we call a non-included side. Okay, it doesn't fall between them. And so side C is over here on the left, and then side A is over here. So we want to find those. I have to use the angle and the side I know. Angle A we're going to find by just taking 180 minus 112 minus 32, and that gives me 36. So this is going to be 36. So angle A equals 36 degrees. All right, so let's find side A first. I'm going to use angle B and side B, and I'm going to take the sine of angle B, which is a sine of 112, over side B, which is 21, equals sine of 36 over side A. Well, at this point, all you have to do is cross multiply and solve. A times sine of 112 equals 21 times the sine of 36 divided by sine of 112. And we get A equals, what's that going to be? 21 times sine of 36 divided by, oops, that was not divided by. Divided by sine of 112. And I get 13.3. And it should be miles for this case. Now to find, what do we still need to find? I need to find side C. I'm still going to use the 112 and the 21. Sine of 112 degrees over 21 equals a sine of 32 degrees over C. And I'm just going to go to my calculator and do 21 times sine of 32, cross multiplying there. And then to get the final answer equals, and then divided by sine of 112. And I got 12.00, which from rounding to the nearest tenth gives me 12.0. So that is C, is 12.0. And what did we say A was? 13.3. Make sure everything's proportional. 32 is my smallest angle. 12 should be my smallest side, which it is. 36 is my next smallest angle. Then I go 13.3. So again, always a quick double check. Now that's just taking a triangle, and for an angle side, or what we call angle side angle, we can just go directly to the law of sines and we can find all the missing parts, the the one angle is always going to be 180 minus the two others, and then we can use law of sines. All right, now some situations here. And a lot of times, they just make sure you read this and make sure you're able to draw out the scenario. It says to find the distance AB across a river, a distance BC of 1,056 meters is laid off on one side of the river. It is found that angle B equals 105.4 degrees and angle C equals 17.5 degrees. Find AB, round to the nearest meter. Okay, so here is our river. And a little bit goes the understanding of how they're describing this. BC is on the same side. It's on one side of the river. So it is both B and C are going to be on the same side. So if I call this B and this C, and I draw that, that is going to be 1,056. A is somewhere over here. We cannot assume it's a right triangle, so don't draw it right over here. I'm going to move A to this point here. And if you take a look at that, oh, let's see if I can make that a little. Okay. Then we are looking for AB, which I'll call X. It is found that angle B is 105.4. Well, that's one reason why I moved that A over there a little bit, because I knew that was an obtuse angle. So that's 105.4 degrees. Angle C is 17.5 degrees. All right, we need to find X. Well, I know this 17.5 is across from the X, and I know my other angle. I don't know this side, nor can I compute it, but I do know 1,056, which is opposite of angle A. So I'm going to need to figure that out. So that's going to be, that's easy enough. We're going to take 180 minus 105.4 minus 17.5, and we get 57.1 degrees. Okay, so that is 57.1. All right, using the law of sines, I can take the sine of 57.1 degrees over the opposite side, which is 1,056, equals the sine of 17.5 over x. Okay, cross multiply x times the sine of 57.1 equals 1,056 times the sine of 17.5. Divide by the sine of 57.1. And let's see what we get here. 1,056 times sine 17.5 equals, divided by sine of 57.1. And I got 378.2, and it says round to the nearest meter. So that's going to be 378 meters. Okay, again, just using the law of sines, making sure we draw everything correctly. All right, now I think you're going to flip it over to the other side. One thing that comes up in dealing with navigation, a lot of times they'll talk about a plane or a ship and their bearing. Okay, and this is something that's usually pretty new or different. And this is how we measure a bearing. Okay, now here's your definition. A bearing is the measure of an acute angle from due north or due south. So if somebody says we're traveling on a bearing of north 40 degrees east, so you go to the north line, you go 40 degrees east off of that, that plane or that boat will be traveling along that line. If we're traveling north 60 degrees west, okay, north 60 degrees west would be in this line. This would be in quadrant 2 if you want to think about this as your origin. And northeast, think about northeast, that would be quadrant 1. So you kind of got northeast, northwest. This will be southwest, and then this will be southeast. And so just think about your directions to kind of think the direction you're heading. Now you do have to watch the angle because the angle is always off the north or south line. So south 30 degrees west, you would go 30 degrees off of that south line. South 75 degrees east, you would be going 75 degrees off of the south line. Okay, because we've been doing a lot with reference angles, and reference angles always with the x-axis. Well, this is the opposite. This is always with the y-axis. But again, you got your northeast, you got your northwest. If it's southwest, it's going to be in quadrant 3. And if it's southeast, it's going to be in quadrant 4. All right, an example that deals with bearing. A boat is sailing due north at a rate of 10 miles per hour. The boat records the bearing of a lighthouse as north 10 degrees east. 2 hours later, the bearing of the same lighthouse is north 35 degrees east. Okay, 2 parts we have to answer. How far is the ship from the lighthouse the second time? And if the boat follows the same course and same speed, how close to the lighthouse will it approach? All right, we're told a couple things. The boat is sailing due north. Okay, so I'm going to just kind of use this for the direction of the boat. And the boat is going to start right here. Okay, the first time it sees the lighthouse in a bearing of north 10 degrees east. All right, you got to figure out where is that lighthouse. Let's say this is the first time it sees it. Where is that lighthouse in relationship to where the boat is? Well, what you got to do is you got to go to the north line. You got to go, I'm going to erase this here, so don't draw this in just yet. You got to go 10 degrees off of that. And then I'm going to draw a line to that point. Okay. That right there. Okay, and actually let me move this back. Whoops. Will it let me? There we go. Nope, that didn't work. There we go. Okay, this angle right here is 10 degrees. And let's say this is the lighthouse. And I'm going to erase this part right there. There's your lighthouse. Now the boat is going to travel north along this line. 2 hours later, the bearing of the same lighthouse is north 35 degrees east. All right, again, I'm going to put a line in here that I'm going to erase so you put it in here. Question is, has the boat passed the lighthouse or is it still below it? Well, since it says north 35 degrees east, that means that the boat still has to be below there. And if I take a look, and north 35 degrees east would mean this angle right here is 35 degrees. Okay, I'm going to get rid of that line. And so this is the first time we sighted the lighthouse. Here's the second time we sighted. Since it was 22 hours in between and the boat is traveling 10 miles per hour, that means this distance right here will be 20. All right, it says how far is the ship from the lighthouse the second time? That would be this distance right here. Now, if you notice, this is the triangle I'm going to work with right here, those 3 sides. This is 20, that's the length. This is X, this is 35 degrees, this is 10. Well, this 35 I need to use, but it doesn't help me. I need to figure out that angle there. Well, this is a straight line. We got to take 180 minus 35. And that's going to give me 145. That's going to be this inside angle. Since that's 10 and that's 145, I can figure out this angle here, and that's going to be 25 degrees. Once I got that angle, I can find X because I can do sine of 10 degrees um, over x equals sine of 25 degrees over 20. All right, go ahead and figure out what x is. I take 20 times sine of 10 divided by sine of 25. I get 8.2. Nearest tenth is fine. X equals 8.2 miles. Now, if the boat follows the same course and the same speed, how close to the lighthouse will it approach? I don't think the speed actually matters in this case. How close will it approach? The closest it will approach is when that is a right angle. Let me move that down there. Okay, when that is, and I'll call it Y, and if that's a right angle, that is the smallest distance between that line and this lighthouse. Well, I know I have this 35-degree angle. I'm going to have to use X as 8.2. I can't get around it. I'm going to have to find Y. So if you look at what we have, I'm going to draw it over here. This is 8.2. This is 35 degrees. This is a right angle, and this is Y. I can use my regular right triangle trig. I don't have to use law of sines. Law of sines will work, but I don't have to use it because Y is opposite, 8.2 is hypotenuse, and I'm going to take the sine of 35 degrees equals Y over 8.2. And to solve that, I just multiply 8.2 times sine of 35. And I get 4.7 miles. Okay, so the answer to part A, how close is it the second time, is 8.2 miles. If it follows the same path, how close will it come to the lighthouse? It will come 4.7 miles away from it. All right, the hardest thing on these is coming up with the drawing because you have not used bearing typically to this point, so it's a little more difficult. So you really got to think about it and see how you're drawing out the figure. All right, let's take a look at that next one on your guided notes. An airplane is sighted at the same time by two ground observers who are 3 miles apart and both directly west of the airplane. They report the angles of elevation as 12 degrees and 34 degrees. How high is the airplane in the air? Okay, we'll go nearest mile or nearest tenth. Now, I want you to think, what would the drawing look like? Okay, you got two observers. They're west of an airplane. Angles of elevation 12 and 34 degrees. So here's what I want you to think. Here is the airplane. This would be an accurate drawing. This would be one person. This would be the second person. Now you got two angles of elevation. It's important that you put these in the right spot and you correctly, I guess, label them. Because this one could be 12 or 34. This one could be 12 or 34. Well, if you think about it, one has to be 12, one has to be 34. The further away it is, this will be the smaller angle. And as that person keeps getting closer to the airplane, or whoever's closer to the airplane, this is my second angle. That is the angle of elevation. That is 34 degrees. We want to know how high the plane is in the air. That will be that perpendicular distance. So then we got to find H. Okay, to solve this problem, I got to find H. I don't necessarily have enough information to find H directly. I'm going to have to do this in 2 steps. They say these 2 observers are 3 miles apart. That means this distance from here to here is 3 miles. I know this is 12. If this is 34, these 2 have to add up to 180. That means this is 180 minus 34, which is 146 degrees. That also means that if I add these 2, this third angle, those 3 angles have to add up to 180. So if I take 180 minus 12 minus 146, I get 22 degrees. So that's going to be 22 degrees. Well, in order to find H, I know 34. If I can find either this length here or this length, I can find H. Well, I'm going to be able to find this length here using law of sines. So you got the 12 degrees, we'll go with the X. And then the 22 degrees will go with the 3. So I'm going to take sine of 22 degrees over 3 equals the sine of 12 degrees over X. All right, go ahead and use your calculator, cross multiply. You get X times the sine of 22 equals 3 times the sine of 12. Divide by the sine of 22. And what do I get? 3 times sine of 12 equals divided by sine of 22 equals. And I get, and I'm going to round that to the nearest tenth, 1.7. All right, I'll go shut this door real quick. All right, so we got 1.7 there, and now we have enough information to find our height. So 1.7 goes here. If you have a right triangle, law of sines works for the right triangle, but you don't need to use it. We can just use regular SOHCAHTOA. Opposite would be H, hypotenuse would be 1.7. Sine of 34 degrees equals H over 1.7. So I'm going to take 1.7 times sine 34, and I'm going to get 0.95, and I'm going to round that to the nearest tenth, so it's going to be 1.0. So the height is 1.0 miles when we're done. Okay. All right. I know there's one more on there, but we're not going to worry about this one. It's not going to affect any of the homework. Go ahead and here is your homework. Get as many done here as you can. It's going to be due Monday, and then we'll go over this, and then we'll also finish up the second part of section 7.1. All right. Thank you.